All right, awesome chemistry people. Today we're going to talk about the mole, and we're going to do some mole conversions. The mole conversions that I'm going to do are actually going to come from your homework packet. So if you get those out, you could do those together with me, and then it's a few less that you actually have to do. We need to know two different conversion factors in order to do these mole problems. The first one says 1 mole is equal to 6.02 times 10 to the 23rd. That conversion factor just is based off of the fact that 1 mole is kind of like saying a dozen. It's how many are there. So we can count out anything with 1 mole. We can count out a mole of pencils, we can count out a mole of calculators, we can count out a mole of atoms like we do in chemistry. So with your 6.02 times 10 to the 23rd, it's a very, very, very large number because atoms and molecules and formula units are so super tiny. So we can use it for anything, but in chemistry we just use it for particles. So for the 3 different types of particles that we talk about in chemistry, a particle can be an atom, a particle can be a molecule, U-L-E, and a particle can also be a formula unit. So we have atoms, we have molecules, and we have formula units. For your atoms, that's just a single element from the periodic table. So we have an atom of ruthenium, we have an atom of cobalt, we have an atom of silver. So any element that's on the periodic table we have an atom of. If we have a molecule, that's just one covalent compound. And if we have a particle, which is called a formula unit, that's one ionic compound. So the only difference there is formula units are ionic, molecules are covalent. Now your other conversion factor that you need is right here, that 1 mole is equal to your molar mass, which is in grams. This molar mass, if you don't know how to find it, look at my last video on how to solve for molar mass, and that'll tell you how to get that number. Or if you pay attention in just a few minutes, we'll go through that process. Now on this problem that I highlighted, this number 2, it says find the mass of 1.112 moles of hydrofluoric acid. Now hydrofluoric acid is HF. We're going to need that information here in a little bit. And we need to figure out which conversion factor or factors we need to do the problem. So we're going to look at your conversions, and we have 1 mole is equal to Avogadro's number in particles, or we have 1 mole is equal to your molar mass in grams. We're given moles. We want mass, which is grams. So if we want to go from moles to grams, we're going to use this conversion factor that 1 mole is equal to your molar mass. So I need to find the mass of my hydrofluoric acid. Hydrogen has a mass of 1.01 grams. I usually round to 2 decimal places to keep my sig figs happy. And then fluorine has a molar mass of 19 grams. To find the molar mass, all you do is add these together. So we're going to just add them up. We get 20.01 grams is equal to 1 mole. So now to do this problem, what you do is you're going to start with the number that's given in your question. The number that's given in our question is 1.112 moles. Now we want to get rid of moles and we want to go to grams. So that means that we're going to use our molar mass conversion. The molar mass conversion tells us that 1 mole is equal to your molar mass, which we found to be 20.01 grams. Because we have mole on top and a mole on bottom, it cancels. So now to get our answer, we just plug it into our calculator. 1.112 times 20.01. And we get this long answer here. We're going to look at our sig figs. We start with 4 sig figs in our measurement. So that means that I have to round this answer to only have 4 sig figs. So we get 22.25. The unit that didn't cancel is grams, so that's my unit. So if we want to check our answer on your homework packet, you should check the bottom and it should say 22.25 grams. Now the next problem that we're going to do together, it says how many moles of barium nitrate contain 6.80 times 10 to the 24th formula units? So if we look at our conversion factors that we had here, 1 mole is equal to 6.02 times 10 to the 23rd particles. A formula unit is a type of particle. So what we're going to do here is we're just going to use that one-step conversion of moles to particles. So we always start with the number that's given in our question first. The number that's given in our question is 6.80 times 10 to the 24th formula units. Now we would need to get rid of formula units and go to moles like the question asked. So what we're going to do is we use Avogadro's number in the bottom, 6.02 times 10 to the 23rd formula units. That's equal to 1 mole. Formula units on top and bottom cancels. That leaves us with the mole that we need. So now we just do our math. Multiply all the way across the top, multiply across the bottom, divide the two. So you're going to end up with 6.80 times 10 to the 24th divided by 6.02 times 10 to the 23rd. It equals, we started with 3 sig figs here, so I need 3 sig figs down here, so you get 11.3. The unit that didn't cancel is mole. So our answer is 11.3 moles. So both of these so far have been one-step problems. Now if we go to the back, the one that we're going to do is number 16. Number 16 says how many formula units are in 1.4 grams of lead-2 chloride. So in this question, we have grams, we want formula units. We don't have a conversion that goes directly from grams to formula units, so what we need to do here is use both of our conversion factors. We're first going to take our grams and go to moles with our molar mass. Then we're going to go from moles to formula units with Avogadro's number. So we need the molar mass of lead-2 chloride. To get the molar mass of lead-2 chloride, we need a formula. So PbCl2. Your molar mass, lead, on the periodic table has a mass of 207.2. Each chlorine has a mass of 35.45. So we're going to get a molar mass of 278.1 grams is the mass of 1 mole. So we're going to use that number to plug it into our equation in just a second. So now I go back to my assignment. I have 1.4 grams of lead-2 chloride. I first need to get rid of grams and take it to moles. How I go from grams to moles is by using my molar mass. We found our molar mass just a second ago to be 278.1 grams. That's the mass of 1 mole. Grams on top, grams on bottom, that cancels. Now that I have moles, I can take my moles and go to formula units, which is what the question's asking for. 1 mole is equal to 6.02 times 10 to the 23rd formula units. Mole on top, mole on bottom, that cancels. That leaves me with formula units, which is what the question's asking for. So now I'm going to multiply all the way across the top. 1.4 times Avogadro divided by the bottom, 278.1. So 1.4 times Avogadro divided by 278.1. And we get that for an answer. I started with 2 sig figs down here, so my answer has to have 2 sig figs on the other end. So we're going to have 3.0 times 10 to the 21st formula units for your answer.